This is Math 10C. Welcome. Today we are looking at lesson 7.5. Chapter 7 is all about systems of linear equations. 7.5, we, in the first part, looked at how to solve a linear system using the algebraic method called elimination. And in this lesson, which will be part 2 of 7.5, we're going to mostly focus on application questions. Before we get to that, you'll see on this first page of your notes that there are 3 warm-up questions. I would like you to pause the video, work through these 3 questions, and then restart it when you are ready for me to go over the answers with you. Okay, you can pause the video now. All right, hopefully you've completed the questions. For question number 1, we are interested in the equation we have above, the 4x plus 2y equals 12, and we're looking for an ordered pair that makes the equation true. So I'm going to go with my x value being 5, so that 4 times 5 gives me 20, and I want my final answer to equal 12, so I'm going to have to subtract 8 from that. In order to get 8, a negative 8, I'm going to have to multiply this 2 by a negative 4. So then 20 minus 8 equals 12, and my ordered pair is 5, negative 4. So this is the ordered pair I'm going to use as I work through the next 2 questions. If you had a different ordered pair, that's excellent, because you are going to see that the answer will be the same no matter what ordered pair you chose. Question number 2. We want to divide both sides of the equation by 2 so that we get this new equation, 2x plus y equal to 6. And then we want to find out, will that ordered pair of 5, negative 4, the one that I chose, will that make this equation true still? So I'll substitute in 5 in place of x, negative 4 in place of y. 2 times 5 is 10, minus 4. Is that equal to 6? Yes, it is. So my ordered pair is on the same line. So even though this equation looks different, the relationship between x and y is exactly the same. So the same ordered pair is on both lines. Question number 3. This time we're asked to multiply both sides of the equation by 3. So what happened there? Let's try this again. Multiply both sides of the equation by 3. I get 12x plus 6y equals 36. And again, I'm curious, if I do 12 times my x value plus 6 times the y value, will I end up with 36? My x was 5. My y was negative 4. 12 times 5 is 60. 6 times negative 4 is negative 24. Is that equal to 36? Yes, it is. So when I multiply both sides of an equation by some number or divide both sides of the equation by some number, it doesn't change the relationship between x and y. Let's take a moment and just look at, if we looked at the graphs of these, why is this happening? So we'll have a look at Desmos here. And we're just seeing a small section of Desmos. So let's see if I can adjust my window. Hopefully we can see a little bit more. We'll minimize this a bit. There we go. You can see that I have 3 equations written down. Right now we're only seeing the 4x plus 2y equals 12. And there we go. You can see that's the equation that's highlighted. We'll keep it coming over here. So let's make this a little bit bolder, easier to see. So now I'm going to highlight my second equation. I don't know why it keeps sliding over. Okay, we'll try this. So if I turn on my second equation, you'll see my green line, it overlaps exactly with my red line. So the 2x plus y equals 6 is exactly the same line as 4x plus 2y equals 12. And we'll see, same thing for 12x plus 6y equals 36. All three of those lines overlap exactly. We would say they're coincidental, or they coincide with each other. So if both sides of a linear equation are multiplied or divided by the same number, then the set of ordered pairs on the line does not change because we have the same relationship between the x's and the y's. So this next bit of information, notice in this first equation I have a 3y here. And then I have this second linear equation where I'm told 3y is equal to 5x plus 1. So that means I could do a substitution and replace the 3y with a 5x plus 1. All right. So kind of reviewing ideas, kind of clarifying what we talked about earlier. Let's shift gears now and start looking at some application questions. Here I've given you a problem-solving strategy. So you should take a moment to read through these. I'm going to go ahead and look at some examples, and I will follow these steps as we go through the examples. Here's the first example. Hakeem invested $15,000. He put part of it in a term deposit paying 4% interest per year, and the remainder of it he put in a treasury bill that paid 5% per year. You may wonder, well, why doesn't he put it all in the treasury bill? Well, often with investments, you don't know in advance how much interest you're going to earn. If you put something into a guaranteed interest investment, typically the rate of return is lower. So the percent interest is lower. So this is probably a hindsight question where after the fact, he discovered that one investment did better than the other, earned more percent interest. After a year, we know the total amount of interest. So notice in this question that we have two types of information, and each type is going to correspond to one of the equations. We have here a total amount invested, and then we have a total amount of interest. So one of our equations is going to talk about how much money was invested, and the other will talk about how much interest was earned. So we have these two interest rates. Often we'll write a let statement to define the variables, but sometimes setting up a table to organize our information is going to be more helpful. So as I said earlier, one type of information we have is the amount of interest. The second type of information we're given, I should say the first is the amount invested, the second is the amount of interest. And we'll pull this over a little bit more. There we go. So what we're asked to find is how much Hakeem invested at each interest rate. So that's a clue of how we'll define our variables. So let's say Hakeem invested X dollars at 4% interest, Y dollars at 5% interest. The total amount he invested was $15,000. Setting it up in an equation like this is nice because that's telling me my first equation. Then we're told about the amount of interest. Well, we know the total amount of interest is $690. But how much interest did he earn in the 4% investment? Well, if we take that amount of interest, I should say that 4% interest rate, and I'll want it in decimal form, and multiply it to the amount of money he invested, that will give us an amount of interest. And so similarly, in the 5% investment, we can take 0.05 times y. If we add those two up, we'll get the total amount of interest that was earned. There we have a system of linear equations. Why don't we review solving by substitution? Even though this is 7.5, which is looking at elimination, let's just review substitution. I'll ask you to pause the video at this point, solve this equation using substitution, verify your answer, and then write a sentence explaining what the x and y values mean. So you can pause the video now, restart once you finish this question. Here you can see I've begun the question. I've isolated the y in the first equation, and then I've set up the second equation to substitute that expression that's equivalent to y, negative x plus 15,000, in. Then I will distribute this 0.05 into the brackets and go through and solve for x. There I've distributed. Now when I combine the x terms together, I will get negative 0.01x. And I think right away I'm going to subtract the 750 on both sides of the equation. And so this negative 0.01x will equal negative 60. Divide out the negative 0.01. And we'll end up with x equaling $6,000. Well, I'm writing fairly large, so I'm running out of space. But I'm going to take this $6,000 up to my first equation, and I'll substitute it in there to find my y value. So I should be doing blue here again. My y will equal negative 6,000 plus 15,000, which will give me a y value of $9,000. Then we should verify. Let me make some space here. I've made some space, but still it's a little bit tight, but we'll make it work. My x value is 6,000. My y value was 9,000. And so we get 240 plus 450, which is equal to 690, which is what the total amount of interest we were told that Hakeem invested or earned in his investments. So again, because this is an application question, we do need to write a conclusion in words. So here we go. Hakeem invested $6,000 at 4% interest and $9,000 at 5% interest. That is that example. On to question number 5. 45 people were surveyed about their use of social media. 1/3 of the people reported heavy use of social media. Some of the people were students, 80% of whom reported heavy use of social media. The rest of the people were adults. We want to know how many students were in this study. So once again, let's take note of the two types of information we're given in this question. First of all, we're told about the total number of people that were surveyed. Secondly, we're told about people who made what they described as heavy use of social media. So those two types of information will be what our two equations are talking about. So what we want to find is how many students were in the study. So I guess against my better judgment, I'm using S as a variable. I often confuse my S's with 5s if I'm not careful. And we're going to say A will be the number of adults that were in the study. We were told a total number the number of students plus the number of adults is going to equal 45 people who were in this study. Next, we're told about those who were heavy users of social media. So we're told 80% of the students were, so we're going to again put it in decimal form, 80% times the number of students, 60% of the adults, so 0.60 times the number of adults, and in total, there were how many people? 31 people. Took me a little bit to scan through because it's not written with digits. 31 people. There we go. We have equation 1, equation 2, a linear system that we can solve. So again, I'll ask you to pause the video and solve it. This time, I'd like you to solve using elimination. So remember, with elimination, we want to take one or both equations, multiply them by a number so we get matching coefficients so that we can add or subtract the two equations to eliminate a variable. Pause the video, try it out, restart the video when you're ready to see my solution. So as you can see, I've chosen to multiply equation 1 by 0.6. So this time I didn't multiply the second equation by 10 in order to get rid of the decimals because I thought, oh, the decimals aren't too hard to work with. Remember, easy to make the mistake of forgetting to multiply the 45 by 0.6. So make sure each term on both sides of the equation get multiplied by that 0.6. Now I have matching coefficients with my A variable. They have the same sign, so I will subtract my two equations in order to eliminate the variable. 0.8 minus 0.6 is 0.2. And 0.6 minus 0.6 cancels out. I guess it would have been helpful if I had written down that 0.6 times 45 is equal to 27. So 31 minus 27 is equal to 4. Divide both sides by the 0.2. And we'll get our value for the number of students being equal to 20. Now this is all we're asked to find in the question. So if we're writing a test and we're in a hurry, we could stop here. But it would be wise for us to solve for the A value, verify, just to make sure we haven't made any mistakes. So I'm going to do that, and then we'll write down the sentence answer. So as you can see over here, I have solved to get the number of adults being 25. Then as we come back here, and again, notice I alternated equations, used equation 1 here to solve for A, then I used equation 2 here to do my verifying, and it looks like my solution works, and so I can write my sentence answer, which is that the study included 20 students. Let's look ahead to the next question. Check your understanding. So you can pause the video. Yep, pause the video work through this question. Once you're done, restart it, and I'll show you my solution. Here you can see how I've set up the equations, very similar to the first example that we did earlier. This one I'm going to solve using elimination. So once again, I'm going to take my first equation and I'll multiply it by 0.6. So you'll notice for both of these, I'm multiplying it by the smaller number or the smaller interest rate. When I say both of these, I mean this question and the previous question. The reason I'm doing that is because I'm thinking ahead so that I know that when I'm going to subtract these two values here, I'm going to end up with a positive coefficient. Now, it would work out perfectly fine if I multiplied both both terms, that whole equation, by 0.08, but I'm going to have a negative coefficient. And I know that I make more mistakes with negative coefficients, so I'm choosing to do it this way. Just continuing on here, now that I have the matching coefficients, I can subtract the two equations, get my x value, plug that into the first equation to get the y value. Then I can verify in the second equation and write my conclusion. So I'm not going to bother showing the verifying this time because we've done that a number of times. Just to keep us going here, there's my conclusion. Next example. If this is January 2024, when I'm recording this lesson, you can skip this example and the next check your understanding question. But if this is some point in the future, then it would be wise for you to stick around for this question. This is a unique question because as we read through it, it looks like there's only one type of information. And it looks like it's just amounts of mixtures. But what we're given is acid concentrations of 60% and 95%. And we're told that there's an amount of solution for each of these. So let's say that I have X milliliters in the 60% solution, and I'll have Y milliliters in the 95% solution. And then in total, I'm going to have 2,700 milliliters. So that gives me one equation. But notice that in the question, we were told that we're going to end up with a 70% solution. So we're mixing 60% with 95%, and somehow we're ending up with 70%. We haven't made use of that 70% yet. So what we're going to think about is the amount of pure acid. So if we think about X amount of solution, X milliliters, 60% of that volume is pure acid. So that's going to be, for my second equation, 60% of X is pure acid. And 95% of Y is pure acid. But here's the tricky thing. 70% of the 2,700 milliliters is pure acid as well. And so that's where we're getting our second equation from. With this much set up, again, I'm going to encourage you to solve this using elimination. When you're done, restart the video, and then you can see my solution. So you can pause the video now. So here I multiplied the 0.7 by 2700 to get 1890. And then I took the first equation in green and multiplied it by 0.6. So that would give me matching coefficients with my x variable, and then I can subtract the two equations and solve for the y. Substituting into the first equation, I can solve and get x is about 1928.6. The question didn't tell us how to round, so I'm just choosing to round to the nearest tenth. Typically, you can expect that you'll be told how to round an answer like this. Then we need to verify and write a sentence answer. You'll notice when I verify that the value that I'm getting here, 1889.99, is close but not exactly the same as the 1890. And that's because these two values that I had for y and for x were approximate values because there were lots of decimal places and I chose to round off. My sentence answer will conclude that 1929, here I rounded to the nearest whole number, that many milliliters of 60% solution is mixed with 771 milliliters of 95% solution. Next page is a check your understanding question. So you can try that one, restart the video, and compare with my answer. You can pause the video now as you go ahead to complete this question. Here's my setup. So once again, we have percentages of a certain substance. In this case, it's silver. But then we have some alloys, which are mixtures of metals. So the 50% silver alloy means that half of that mass is pure silver. The 25% silver alloy means that 25% of that total mass is pure silver. So our blue equation, the second one, is talking about the mass of the silver. And again, where we get this 250 from is taking the 625 and multiplying that by 40%. This time I chose, instead of multiplying the first equation by a decimal value, I chose to multiply the second equation by 4 because I recognized that 0.5 is a half, 0.25 is a quarter. If I multiply that equation by 4, I get rid of the decimal places. And at the same time, I get matching coefficients with my y variable. So then with these matching coefficients, I can subtract my two equations to get the value for x as being 375 grams, and then solve for y to get 250 grams. Once again, to save time, I'm not going to show the verification, but that's something that you should do. Do make sure that you write a sentence conclusion, because it's kind of like when you write an essay, you have an introduction where you state any assumptions you make or what you're planning to accomplish. So this is like the introduction. And then you show evidence. So there's the evidence. And then you write your conclusion. There's the conclusion. Here's another check your understanding question for you to try. We've previously looked at questions with speed, time, and distance. This one's a little bit different, I think. Try it out anyhow. When you are ready, start the video to see my solution, but you can pause it for now. Here's my setup for the question. So notice that as we read through the information we're given in the question, we're given information about distance, and we're also told that the trip took 14 hours, so we have a total time. Speeds aren't something that we combine together, and so typically our equation won't look at speeds, although there are exceptions to that as well. Once we have these two equations, then we can again multiply or divide one of them to get matching coefficients. In this case, I chose to divide that second equation to get my coefficient smaller and then multiply my first equation in order to get the matching coefficients. If you didn't do it this way, that's perfectly fine. This is just a variation I wanted to demonstrate for you. Now I can subtract my two equations, solve to get the y, substitute to get the x. Then notice we are asked in this question to find distances. I chose to make my variables time instead of distance, just because it makes the question or the equations easier to work with. So once I go through and solve for x and y, I need to remember those are times, and in order to find distance, I need to multiply a time times a speed. Funny looking s. If I do time multiplied by the speed, as in hours times kilometers per hour, it's going to give me a distance, which will be in kilometers. So, unique question here. Priya traveled 810 kilometers by bus, 400 kilometers by train. And that ends this lesson.